Good afternoon, everyone. Welcome to the third lecture. Let us wait for the other participants for joining in the meeting. Let us wait for a few minutes, okay?
Hello, am I audible? Hello,
Yes.
hello,
Yes, ma'am.
hello, hello. Am I audible?
Yes, ma'am.
Okay, good
Yes, ma'am.
afternoon. Yeah, good afternoon, everyone. So, we were discussing about in last class what we were discussing. We were discussing about the types of cements in materials, right? So, let me share my screen then. I'll start sharing. I think those who had to join, they have already joined. Uh, One, give me a second. Colored cement was, and I think we had completed till colored cement. And okay, We had completed colored cement. Now this is your air entering cement. Okay, material testing. Okay, so is my screen visible to you all? Is my screen visible? Hello? So I think it's visible. Okay. So
Yes.
okay. So next type one was what? The next type of cement was your air entering cement. And what does, why it's not moving? Okay. So what is air entraining cement? Air entraining cement is a special type of cement which entrains tiny air bubbles in the concrete. Okay. So these are your cement which will help you in creating or developing some of the air bubbles inside your concrete. When you mix a concrete and you're using it, then what happens? This air, if you use this air entraining cement, there will be bubbles developed. And now why we need to develop these bubbles? Because you know this one, when water in concrete gets freeze due to low temperature, it will expand in very cold places. Okay, when you are in a very cold places where you have your temperature below 0 degree minus in, okay, when it is below 0 degree in minus, then what happens? Your in inside the concrete, when you have used the concrete, your water, if there are some water present in the voids, what will happen? That will get freezed, and then again when it gets freeze, what will happen? It will occupy, when it is in liquid form, it may move from one space to another, from one void to another. But when it is at a very low temperature and it becomes solid, your this water which is flowing inside the concrete, if it is present, then what happens? This may freeze, and if it freezes, it will take up this kind of shape. Okay, this one is the liquid, so it will become obviously uh, it will take more space as compared to your the water present in the concrete which was flowing in the liquid form, right? So it will expand your this portion due to the freezing of the water. What will happen? Your this water will expand. So for that we have air bubbles. Okay, so when air entraining cement is used, what will happen? The air voids in the concrete provide space for water to expand without cracking concrete. But this type of cement does not provide high strength in concrete. Okay, so if you want to use this kind of cement where you think you're at a very cold place, where you know that your waters inside the water which are present inside your concrete may freeze, and then they may expand its shape. So if they may expand, so for that you can use your air engineering cement which will create bubbles, inside your cement, which will create bubbles inside your cement, and these will help in uh, keeping the water which freezes. This will give space to the freezed water, this one. Suppose if this is the water which has freezed and expanded, since you have this space, your this portion you have free for the water to expand, so it may come this side, your liquid in liquid form, and then it may freeze here. So you can use your air entraining cement in this kind of low temperature areas also. Okay, so what are the uses? Especially it is used in the areas where the temperature, as we already know now, that it is used in temperatures where it is very low, and also it also resists sulfate attack. Okay, this kind of cement. Then it is used where the de-icing chemical is. Okay, so next is your expansive cement. In the hydration process, the expansive cement expands its volume. Yeah, okay. It can be possible to overcome shrinkage loss by using expansive cement. This is also another kind of cement where you want to limit your shrinkage loss. You don't want your concrete to lose its that there you don't want that your concrete may lose its strength due to shrinkage. Once your concrete shrinks, what will happen? It will start cracking more easily. So you will want your shrinkage to be less, so you can use in those places, you can use your expansive cement. Okay. Uses of expansive cement, it is used in the construction of the pre-stressed concrete components. It is also used for sealing joints and grouting anchor balls. Okay. When we construct this pre-stress members, when we construct this pre-stress concrete members, what happens? You are constructing the member in a site and then bringing it to the site. Okay, this is off-site, this is on-site. You prepare this and then you bring to this site of the construction work. So during that time, what may happen? If you take more time, you are, suppose two, you are taking, suppose 2 3 days, or you want you for due to some reasons you got delayed, and that may create shrinkage here. If you have used some this thing, the different cement if you have used, then this may happen, like you have delayed, your work is delayed, and this you have brought this on site uh, after you say the required time which was required to be sent, you are late for that. So at that time also it may this thing, right? What will happen? It will help in lessening the shrinkage volume, and it will help in expanding, okay, expanding the cement so that it is used properly in the site and there is no shrinkage losses also on the side. Also it is used in sealing of the joints and grouting anchor balls. Okay, in the construction of different hydraulic structures also it can be used. So there are, depending upon, as I told you before in the last class also, that what, depending upon the type of construction, your requirements, your purposes of construction, you can choose your type of cement. Okay, you want strength, you can use your Portland cement. If you want your to set fast and then get lesser strength is also no problem. If you want that your strength can be delayed, that also you can use quick setting cement. If you want quick hardening cement, rapid hardening cement, etc. So depending upon your purposes and types, there are different types of cements, like this one was one of the example. So another cement which is there is hydrophobic cement. Now, what is that? It is used to resist the hydration process in the transportation or storage stage. Clinkers are grinded with water, repellent films such as oleic acid or stearic acid. So, sometimes it may happen like you want to reduce the hydration time, or you want to resist the hydration process of the concrete which you have prepared. Okay, you have prepared your concrete here off site, and then here your construction is going on and it is very far off place. It is very far off place from here to here. Say like you, it may take you, suppose 24 hours you say, or maybe more than that, 2 days. Okay, so you want the hydration process to be slow, so at that time you can use this hydrophobic cement. Okay, where this will slow down the hydration process. Once the hydration process is complete, your concrete will attain the desirable strength. Okay, so that means it is ready to give you that much strength. Wherever you use it, it's ready to set or harden. Okay, so for those purposes, like you have you want that your hydration process to be slow, depending upon your situation or circumstances, you can use your hydrophobic cement when you want your hydration process to be slow. These chemicals form a layer on the cement particle, and how this process is done, how this cement, hydrophobic cement, will resist the hydration process, because they have some chemicals which will form a layer on the cement particle, and they and do not allow water to mix and start the hydration process. Okay, so this hydrophobic cement has the property of forming a layer, this layer on the top of the cement, such that your particles do not mix together. You can say your water will not mix together with your concretes, the aggregates or the mixtures, the binding materials. So what will happen? Um, the addition process, that is cement and water, there will be a layer, so they will not get mixed, your cement and water, and as they are not going to mix, so what will happen, your hydration process can be stopped or delayed. This hydration process can be delayed, right? And after some time, it will, your cover or your layer will get reduced when you mix it again on the side. Okay, so you can use of all those purposes. When cement and aggregate are thoroughly mixed in the mixer, right? Okay. When the cement and aggregate are thoroughly mixed in the mixer, protective layers break, and so yeah, as I told you, like see, this will form a layer. Your hydrophobic cement is going to form a layer on the cement particle, and will not allow the cement particles to mix with the water. Right, it will not allow the cement to mix with the water. But once you reach to this site where you want the construction to be done, then what will happen? You will mix this concrete. You are going to mix with the cement, whichever is there, hydrophobic cement. So what will happen once you do the mixing? This protective layer will break and start the normal hydration with some air entrainment, which increases the workability. Okay. Hydrophobic uses is what it is used in the construction of water structures such as dam. This is also another kind of cement which can be used in your dams, because dams take a lot of time to construct. Right, when you're constructing a dam, it will take a long time. It will take a long time. So once you prepare, once you have worked for one day, suppose, and again next day you're going to do. So you need, suppose you have mixed your concrete, sorry, you have the, where is my, okay, you have the uh, cement on the side, you have the water on the side, you have aggregates also. So when you are working for a dam, suppose, then you have constructed half part, then again next day you are going to continue for few days, you are going to for your construction is going to continue until unless the entire dam is complete. So on one day it is not possible to construct a dam. So the next day when you are using, suppose you were mixing something, okay, you were mixing the concrete, you were preparing the concrete, and then the cement and the water is left out there separately. So what you can do, you can, suppose you have already mixed the earlier day, the cement, water, and the aggregate you have mixed together, but for due to some reason you could not work on it, you could not use those things, you could not use this mixes, and so the if you use this hydrophobic cement, what will happen, the cement, tomorrow, the next day, when you again start the construction, continue the construction part, what will happen, these, when you're going to again mix this concrete materials, which are your cement, water, aggregates, what will happen when you mix them, what will happen, again the protective layer, this one will break, and then it will work, as you will have a better workability, so that you can work for the construction of the dam, and you can continue with the construction. Okay, it is also used in the construction of underground structures like tunnel. Yeah, the main reason being that you want to slow down the hydration process wherever you want. It can be not only on these dams or tunnels, etc. In some places, like Yeah, tunnels also. Why? Because they will not take much load. They may not be much strength. They may not have that much strength, but the process will be slowed down. The hydration process. Wherever you want your process to be slowed down, you can use that. Okay. Irrespective of only, don't think that it can be used only on dams or tunneling. Now, these was all your about the cements. The types of cements is done. Now the next one is your MC. So what is your MC? The next material which we are using is your what? MC. Who is this? Oliver 001. Gita Tacho. Am I not audible? My voice is very low. You are telling. Can't hear any voice. Am I not audible? Hello? Hello? Am I audible or not?
Yes, ma'am, audible.
Yes,
Okay.
ma'am.
Some of them said that they can't hear any voice. Ma'am, your voice is too low. Okay. Who was that? Oliver, roll number 1.
Yes, ma'am.
Your mic is on. Unmute.
Oh,
Sorry,
ma'am,
mute yourself.
uh, I want to say something.
Yeah.
Ma'am, I don't know why I can't send message to everyone, ma'am. Then I can't write my roll number in the chat box.
In the chat box.
Yes, ma'am. I can't write it. I don't know
Because
why.
there is a setting, right? Not setting, like this chat one when you open, there is
Yes,
a box where it is written two. So in the
yes,
two
ma'am.
you select everyone.
Ma'am, there's no everyone. I just check it there. That's the ma'am. That's why I'm very confusing here.
I don't know, maybe there is some problem with your Cisco or what. You're using cell phone.
No, ma'am. I'm with my laptop.
Oh, it should have come. The two option is here at the chat box, below the chat box.
Yes.
Just check once. I think it's there. So next, the next type is what? And also one more thing. You know that I'm not going to check the chat box for your roll numbers. I'll be taking the roll number. I'll be calling out the roll numbers at the end of the class because it's not possible for me to look the chat box and note down everybody's. There are so many students. It is difficult for me to note down from the chat box. Okay, so I'll not be checking the chat box for your roll numbers. I'll be calling out the roll numbers and taking myself. Okay. So the next type, the cement is complete. Now the next material which we are going to talk about is your MSN. Okay. So what is your MSN? Hmm? These are your manufactured sand. MSN means what? MSNs are nothing but your manufactured sand, which is a substitute of your river sand. Okay, for concrete constructions. Okay. Generally, what we use the natural sand from the riverbed, or okay. So, but this is the material which I'm talking about is your M sand, which is your manufactured sorry, not cement, manufactured sand. Okay. Why we use these things? Okay, these are your manufactured sand. Manufactured sand, you see the color how it is. It is like a gray kind of color, and it is little bit more siltier. You can see, okay, like angular shaped. These things will be there, the cells will be angular shaped, you see, produced from hard. How it is produced? It is manufactured from hard granite stone crushing. Okay, that's why its color is like that. But when you see the natural sand, what is that color? Like orangey color, no? From the natural sand is how orangish yellow, orangish color. So but this is your manufactured sand, which you should know. Nowadays we use this manufactured sand also, which is more stronger because it is manufactured from what? Produced from the stone crushing of hard granite stone. Okay. The crushed sand is of cubical shape with grounded edges, washed and graded to as construction material. How once it's crushed, your hard granite stone is crushed, what happens? It is washed and then graded, so that it can be used as a construction material. The size of manufactured sand is less than 4.75 mm. Okay, so why we use this manufactured sand when we have already the natural sands in the riverbed? We can find out the natural sands we can get because it is an alternative. Okay, because it is an alternative for river sand. Because you know why? This one, see, there is a difference between the, this is the artificial one, this one is your artificial sand, and this is your natural sand. Natural sand is how the orangish color, right? But this is your gray color. Why? Because it is crushed of the crush of the, when your granite stone is crushed, this is formed your artificial sand, which is your M sand, the manufactured sand. Okay, so why we use? Because this is a good alternative to your natural sand. Okay, because why? Due to the growing, you can see, due to the fast growing construction industry, what is happening? The demand of sand has increased. The demand of sand has increased tremendously, so it is, sometimes it becomes, for us it is not possible to get so much quantity of our, the companies cannot provide the natural sand, because due to the fast growing construction industry, what is happening? It is reducing our, this natural cement is getting reduced. So we are, the construction team is trying, not trying, actually it is already meant used nowadays in most of the constructions, this artificial sand, which is the crush of the granite stones. Okay, so this is used as a replacement of this, because we may not get in all the times, uh, it cannot be provided, your natural sand may not be provided or may not be easily available. So we, but artificial one, what is the usefulness of this? Because we can get in at any time, anywhere we can get when we buy them. Okay, another one is what, why we use M sand? Because due to the depletion of good quality river sand for the use of construction. Yeah, nowadays what is happening, due to the pollutions also, and due to the increasing population also, whatever these things are, unwanted things may be going on. So in like, so much of natural sand is taken out by some of the construction industries, that there are no availability, and if it is available also, the quality has reduced to some, in some of the natural sands you will see the there is depletion of good quality river sand for the use of construction. The use of manufactured sand, this cement, the, not cement, manufactured, the use of this manufactured sand has increased. Okay, another reason for using M sand is its what, availability and transportation cost. Because when you have to, when you are opting for this natural sand, you have to depend upon the person, those who are bringing from the river shore. Okay, but for artificial, it is available in the market. You go to some place, you want the artificial sand, it is readily available. You don't, it is difficult, because it is difficult to get the natural sand. Okay, so one of the most important thing about this is what, the artificial sand, its availability, and transportation cost is also less. Because it's, when you are bringing natural sand from the side of the river side, it, you will need more, the side, your site may be very far off from the natural sand place where it is available in the river side. And also you will need more, this thing, you will need more of the workers, laborers, okay, laymen's, so that they will do what, they will help in getting your natural scent from there, extracting the natural scents. Okay, so it is more costly, the transportation cost is more for you. Again, you have to bring on the side those things, so that is the transportation becomes, the transportation cost is becoming more for that. Okay, okay, since manufactured sand, can be crushed in hard granite rock, it can be readily available at nearby place also. Like, it will reduce the, as I told you, it will reduce the cost of the construction, transportation from far off the rivers and bed. Also, it is dust free, because the cost of construction can be controlled by the use of manufactured sand as an alternative material for construction, right? So the other advantage of the M sand, it is what, it can be dust free. Because why? This size of the M sand can be controlled easily so that it can meet the required grading for the given construction. Like you want the size to be more, you can ask for the artificial sand makers that make in this size, and they'll give you in this size. Okay, because it is obviously the grading. Once you have this thing now, how you have done that from the granite stone, you have crushed those. So when you're crushing and then you are separating, you can separate those things. You want the size to be more, you can use the size. You can ask the artificial makers to make the size to be this much, and then they'll create that for you. Oh, it's going to end only. Roll number 1.
Present, ma'am.
Okay, 1 2 3. Today is 26th. Roll number 2.
Roll number 2, present, ma'am.
3
Yes,
5.
ma'am.
Okay, when I call your roll number, you tell your roll number. Okay, if I say 5, if 5 is present, say 5. If 6 is present, say 6. Okay. 5,
5,
7, 8, 9, 10,
9 present.
10, 11,
11
12,
present, ma'am.
12,
12 present, ma'am.
13,
12,
13,
ma'am.
15.
12.
Yeah, okay, I have given.
Number
15,
number 15 present, ma'am. Number 15 present, ma'am.
16,
Present, ma'am. 16.
17, 18.
17 present, ma'am.
Okay, 18,
17 present.
19, 20, 21,
19, 19.
19. Okay, 20, 21, 22, 23,
22.
22,
23 present.
23 present, 25,
23
Present,
present,
ma'am.
ma'am.
25 present, 26, 27, 28, 29, 30,
Ma'am,
30,
29.
29 present,
Ma'am,
30.
29 present.
Okay, 30, 31, 32, 33, 30,
Ma'am, 32.
32 present, 33, 35, 36, 35 present, 36, 37, 37, 38, 39,
Present, ma'am.
38 present,
38.
39,
Yes, ma'am.
39,
Yes, ma'am.
40,
Yes, ma'am.
41,
41 present.
42,
42 present, ma'am.
44, 45,
Ma'am,
45
43 present,
present,
ma'am.
ma'am.
43
43, yeah,
present.
44,
45 present,
45,
ma'am.
46, 47, 48, 49, 50, 51, 52, 51 present, 52, 53,
53 present.
54, 55, 56, 57, 58, 59,
Present, ma'am. 59 present, ma'am.
60,
60 present, ma'am.
61, 62, 63, 64, 65, 66, 67, 68, 69,
Present,
70,
ma'am. 68 present, ma'am.
68, 69, 70, 71, 72, 73, 74,
74 present, ma'am.
75,
Ma'am,
73 present.
73 present,
74.
74 present, 75,
75 present.
76, 77,
77 present, ma'am.
77, 78, 79, 80, 81, 82, 81 present, 82, 83, 84,
Yes.
85,
85 present.
86,
Be present.
87, 88, 89,
88